Okay, challenge number 67. So this time we have a spatial challenge. The challenge is actually quite straightforward if you look at the pictures. What we have is we're going to have the two, and then we try to find the angle from horizontal space and the distance between the hypotenuse, the so-called. Hopefully you remember your trigonometries from your high school. Then the challenge itself will be actually quite easy to do. On the left-hand side, you can see the map with two dots as the two input point. The first thing for me, actually, I prefer to do pivoting. So it's long to wide format. Because we only have 2 points, so it's easier to compare just as two columns next to each other. So labels header, column framing, special list, so the first fun. If you have multiple points, then we probably want to do some different pairing setup. In Alteryx, surprisingly, this challenge is actually quite easy to perform because what we have, first thing we're looking for the hypotenuse. If we go back to shape, we can see we can do a vertical drop down. We can do the craning. Say that's your perpendicular angle. You have a right angle triangle. What Alteryx, the distance between those two, that's your hypotenuse. That's your opposite. That probably is called your base. Uh, Turns out Alteryx can handle all the things quite easily, straight away, without even doing too much trouble. So the distance gave you the hypotenuse between the points. Key thing is this guy, the direction in degrees. So we don't just talk about the cardinal directions, north, west, east. You can actually get the degrees in there, and that's extremely handy. They, oh, they didn't say what's the distance. Uh, I'm tempted to select kilometers, but I have a feeling they may be in miles, given usually the questions in miles. That's right. Yeah, we look at the directions. So you can see that degree is 58.4 degrees. And yeah, that's distance. Yeah, it's in the miles, 11.25. So okay, 11.25 degrees 31. So they did it probably from north. They kind of like did a bearing. They kind of angle degree between the 2 points where the line is drawn and the lower point. Yeah, I feel like they did things down the wrong way around. Did they? Hmm. Let me think. Maybe I think what Ultrix gave you is actually the bearing. So it's Ultrix probably gave you that as north. So Ultrix probably gave you 58 degrees here. Yeah, my guess is Ultrix probably did north at 0 degrees. Give an answer so we know what the formula is. So the angle, we're looking for 90 degrees minus the direction. Okay, so we're gonna keep it double. Da, da, da. Now, since we're here, we already have the distance miles, which is the hypotenuse. If you know your trigonometry, you can actually find out everything else. Let's put our opposite edge. So you have opposite hypotenuse, that's sine. Oh, so you have a sine theta equals the ratio. So the opposite. So you should have hypotenuse, which is the distance miles, times sine of the angles. So the ANG that should be the base height. Then you can find the adjacent. I don't remember how to start adjacent. Base age. So the base should be the cost instead. So you do have math functions in the Alteryx. People just don't use as much, really. So in this particular case, we may well just find everything out, not just. So the hypotenuse should be 11.25. We have base opposite hypotenuse is 11.25. I cannot spell hypotenuse, so I'm going to go copy, select. We don't care about that. The distance is basically hypotenuse. Degree angles, we converted it, so angle the one we want. Then you have 3 edge. We may well just complete the whole mass. Uh, yeah, since we're here, right angle triangle. One more step. Pythagoras. 这个 answer. SW, if you remember Pythagoras, then you should opposite squared plus your base edge squared. Yeah, that's not squared in power. You got to do power. Power of the opposite edge, 2 plus power of your base edge, 2. Sum of that minus the hypotenuse. So hy. That's that. Oh, I haven't changed the name yet. Minus the distance, the power of distance. You should get 0. So we get a very small number. So that's just due to the rounding errors in the computer's sense. But overall, that's pretty much approximately 0. So indeed, we're doing our right angle triangle in the correct sense. Yeah, overall, it's a very simple question to do actually. Objects again, it just shows off pretty much the strengths in the spatial analysis in Alteryx. Yep, and that this challenge. Thanks for watching.